Hi Math, I'm Andy. Today we're going to look at some properties of exponents, and we're going to be multiplying and dividing with the same base. So let's kind of start just by explaining exactly what is a base. Well, when you have a number, let's say a number x, and it's raised to a power 3, we would call the x, that number x, that's what we refer to as a base. And this little number 3, written in superscript as it is, that is the exponent. Now, that's also, you'll hear it referred to as a power. And what this stands for is that base number becomes the multiplier, the exponent number of times. So x to the third power is really representing a shortcut to multiplication. X times x times x. X is multiplied by itself 3 times. Now, when we start doing math with exponents, we start to notice some patterns happening with the exponents. And so we've developed some properties that involve multiplying and dividing with the same base. Here's what I mean. Let's say that I have 2, the number 2, and it's raised to the second power, which means 2 times 2. And I want to multiply that by 2 raised to the third power, which means 2 times 2 times 2. So when I expand this out, 2 squared, or 2 to the second power, is really 2 times 2. And now I'm multiplying this by 2 cubed, or 2 to the third power. So that is 3 2's. Now when I look at this, 2 times 2 times 2 times 2 times 2, a shorter way, or a shortcut to write this, would be 2 to the fifth power, because there are 5 2's. And so we'll see this pattern emerge where the exponents 2 and 3 relate to the exponent 5. Let's generalize this using variables. Let's take the variable x, and let's raise x to the fourth power. And let's multiply this by another x, and we'll raise this x to the sixth power. Now we know this represents x by itself 4 times, and this is x times itself 6 times. And so that's a lot of x's. That is a total of 10 x's. Here's the x to the fourth, here's the x to the sixth. So if I wanted to simplify that, I end up with 10 of them. Now when I look at these two patterns, I notice something happening. I see that my exponents of 2 and 3, and I have an exponent of 5. 2 plus 3 equals 5. Now looking at this, I have a 4 and a 6 to make 10, and I also know that 4 plus 6 is equal to 10. So by looking at this rule here, by expanding it out and thinking about how they relate, we're actually able to come up with the multiply using the same base property exponents. It is this: when you have the same base raised to an exponent, and it's multiplied by the other of the same base raised to an exponent, a simple way to combine these is to add those exponent values together. As we can see, 2 plus 3 made 5, and 4 plus 6 is 10. So here is our rule for multiplying exponents with the same base. Now let's take a look at dividing some exponents with the same base. You're going to notice that this is very similar. Where multiply was related to addition, division will also be related to another operation. Now, by dividing, I mean this. What if I had 2 to the fourth power, and I wanted to divide it by 2 to the second power? Well, we can think of expanding this out again. 2 to the fourth power is 2 times 2 times 2 times 2. And 2 to the second power is 2 2's being multiplied. Now, through division, we know that when we have the same number on top and bottom, we can cancel those out and make a 1. So this 2 cancels with this 2 and makes a 1. This 2 cancels with this 2 and makes a 1. And all that's left is 2 times 2, which can be shortened as 2 to the second power. Now let's think of it in more general terms. Let's take a look at variables. So let's do it this way. I have a y to the 5th, and I'll divide it by a y to the 3rd. Now we don't know what y is, so we can just think of it as any number. But we do know that y to the 5th represents y times itself 5 times. And we also know that y to the 3rd power represents y times itself 3 times. Now, although we don't know what y is, we do know that when you have the same number divided by itself, you get 1. So in a sense, this y cancels with this y. A 1y on top and 1y on bottom would cancel, creating 1. 1y on top and 1y on bottom cancels, creating 1. And we just end up with y times y. Now to simplify that, we would have y to the 2nd power. And now let's go ahead and take a look at this pattern. When we had an exponent of a 4 on top and a 2 on the bottom, we ended up with a 2. And 4 take away 2 is 2. When we had a 5 in our exponent and divided it by a 3 in our exponent, we got an answer of 2. And we know that 5 take away 3 is also equal to 2. So through this pattern, we're able to generalize and create a property of exponents. And it says this: when you have a number raised to an exponent and you divide it by that same number raised to an exponent, the shortcut is to subtract those powers. And so we've taken a look at 2 separate properties where division is related to subtraction and multiplication is related to addition.